Hope everybody can hear me, and I will also start sharing my screen with the presentation we have on our journey we are on for the last 4 years. So I will start sharing my screen and go to presentation mode. Yes, we're all set. Yes, this presentation will be on the digital twin of Brabant Water and the steps and the journey we've made, and also the way to data-driven operations. And I start introducing Brabant Water as a company. We are a utility in the south of the Netherlands. In the Netherlands, we have 10 utilities providing drinking water. Each utility has its own area. We are in the south, in the province of Brabant. We provide drinking water to about 2.6 million customers, and we do that by 1.3 million connections. And in the Netherlands, every connection has a water meter. So we have about 1.3 million water meters in our asset group. Our distribution network has a size of 19,000 kilometers of mains spread over the province. And as we use groundwater as a main source of drinking water, we have 29 water production plants spread over our surface area. We provide 200 million cubic meters of drinking water each year, and we do that with approximately 1,000 colleagues. And to give you an overview of our surface area, here you can see that we are in the south of the Netherlands, and our surface area has different characteristics. We have several larger cities, as you can see on the map. Especially the Eindhoven region is a very rapid growing region if you look at population. But we also have lots of rural areas. So in the more urban areas, we have lots of customers on relatively short lengths of network, where in rural areas we have less customers and longer stretches of network. So that also defines the layout of our network and the distribution of water. And I don't know, as I not can see you, but I guess you're from all over the world. And the image of the Netherlands is that we are a very wet country. We have lots of water, we have rivers, we have the sea. But also here in the Netherlands, we are facing drought. I guess since the summer of 2017-18, we've had very warm and hot summers that really stretched the water distribution here. And we also see that, also a lot of other users fight for water, especially during the hot summers. And it makes that the whole water system is out of balance. So that's a big challenge for us as a company. And also we have a limit to our sources, as we have permits on the amount of water that we can extract each year. And with a limit to our sources and the increasing population, we have a very big challenge to deal with that. Another challenge for us as a company is retirements. Maybe that's quite common for the utility sector, but we have many colleagues working here for over 30 years, and this group of colleagues is retiring quite rapidly. And we set all these challenges at the beginning of the program, and now we are on a journey for 4 years, are already seeing the whole population of our company changing. So this is a challenge that we are really dealing with, and where we can see the change. Another big change for us as a company is digitalization of the society as a whole. Everybody has a smartphone. You have access to information from all around the world, and our customers also expect this from us as a company. So when there is something wrong in the water distribution, if there is a leakage, people want to be informed and expect from us that we, know what's going on, maybe already on forehand. And the other challenges we have to face is the energy transition here in the Netherlands. We have a lot of renewable projects. Electricity network gets a huge upgrade. So this also affects our drinking water network. And what we also see is the increasing and also changing costs in energy, where energy is one of the main things we add to the drinking water. So increasing costs in energy directly affect us as an organization. So these are the challenges we started the program with. And at the beginning of the program, we set a clear goal. And that goal is in 2025, Brabant Water has a real-time hydraulic model of the distribution network. And we call this the digital twin, and use this digital twin to be able to do data-driven operations. And you see here two words, SOFIA and the Dutch word op pad. We are talking about the SOFIA program. That's the digital twin program. And SOFIA stands for Smart Operations from Intelligent Assets. And the SOFIA program is part of a bigger program where we are, as a company, dealing with all the challenges we have as a company. And that's the op pad, or in English, on track program, where we have different tracks. And the SOFIA program, where we are working on, is the biggest program in the track Our Future. So this is one of the biggest innovative programs. We also have a lot of other innovations running. So this is the goal we started with. And that was in the end of 2021. And I got a question. Yes, we want to have a digital twin of the distribution network. And how shall we start with that? So we discussed this here internally, and we said, okay, we need help and we need time to really define what is a digital twin and what does the digital twin mean for the company and how does it impact the company. So what we did in 2022, we started off by making a blueprint of this digital twin. And we looked in the market for help in order to write this blueprint. And that's the point where we started working together with Idrica, now part of Xylem, where we, based on their experiences, helped and they helped us to write this blueprint. And in this blueprint, we really looked at all aspects of the digital twin. So on the devices we needed to install, the requirements of the devices, the IT aspects, the platform that we needed, but also organizational aspects. So how will this impact the organization? What are new skills that will be needed in order to operate the digital twin, but also to maintain all the devices we are going to install. And then at the beginning of 2023, with this blueprint, we went to our board of directors. We had a very good and intense session with the board of directors, where we really went through all the aspects of the digital twin. And based on this meeting, we got a unanimous go on the program and all the projects within the program by the board of directors. And this was a really important start of the project. And also the ownership of our board of directors is, along the whole journey, very important. So this is the go. From there, we started off with the different projects. Started off tendering of the devices of the IT, and started to implement. And we did that in 2024. This year, we really scaled up in installing assets, and also almost finalized the implementation of the platform. And next year, we will continue rolling out smart water meters, sensors in the network, and also keep developing the platform. So this is more or less the roadmap we went on. In the blueprint, we also set a very clear scope, and I guess this is also part of the success of the project, because you can make a digital twin of many things. It can also be on water quality. It can also be on the condition of the mains. It can also be on other topics. We set this digital twin scope. We want to go from our GIS, which you can see on the background, and I always call the GIS more or less the family picture of our network, to a living model, and then mainly focusing on water flows through the network. So what we want is these 4 scope areas. We want to be able to real-time monitor water flow through the network. If there are any anomalies, we want to detect them. We want to be able to simulate different scenarios, such as leakage, valve closure, or new customers added to the network. And we wanted to be able to know when and where water is leaving the network. We call that the consumption patterns. So this is the scope we set for the digital twin. And how did we set up the program? The main focus is on, and you can see that in the top, data-driven operations. So that's the focus, and we want to do this data-driven operations with the digital twin of the distribution network. And we set up this pyramid with all parts of the project. So we have the base layer, and those are 2 projects, a sensor project where we install sensors in the network, and a smart water meter project where we acquired and are now installing smart water meters at our largest customers. Then on top of that, all these assets are gathering data, sending data to Brabant Water. We have the data platform, and in this case, it's the Xylem Vue data platform. And within this data platform, we're also setting up hydraulic models of all areas, all parts of our network with a specific hydraulic model. So that's more or less where we manage the data, and where the hydraulic models are more or less the engine in the platform. And on top of that, we have the dashboards where we make the data available, and which can also, for instance, be used in our control center, where we have dashboarding, where we can overlook our operations. We can execute simulations. And the outcome of these simulations and dashboards and the actions on that is to really, in a different way, operate our distribution network, to really support our mechanics in the field, to be more proactive. So becoming from reactive to be more proactive and already see if there are any malfunctions in the network, instead of customers calling us to tell us that there is something wrong and that there is a leak, for instance, in the network. And now I will make the step to where we are at the moment. And I start off with the different assets. First of all, the smart water meters. In order to see where water leaves the network at what time, we are installing smart water meters at our biggest customers. And we did the analysis, and if we look at all our customers, the top 10%, so about 120,000 customers, they consume more or less half of the water that we distribute. So for now, we will install smart water meters at this group of customers. And we have 2 water meters coming out of our tender. We install the Kamstroop water meters, and water meters provided by Xylem and made by Xylem. So this summer we started with the installment of these smart water meters. At the moment we have about 8,000 smart water meters installed. By the end of the year we hope to have installed 20,000, and next year we will do the other 100,000. So it's a big step for us, where we're having analog water meters where customers once a year send in their meter readings, and now we go from this 1 meter reading each year to 24 meter readings sent in every day. And the next important asset we are installing are sensors in the network. And on the right, you see a flow meter installed in the network. And we are setting up 100 DMAs. And on the next slide, I will show a picture of the DMAs. So that for each DMA, we get a real-time water balance of how much water is going in and out of this DMA. So we set up the flow meters, and at the flow meters, there is also a pressure and a temperature sensor. And in the DMAs, and that's what you see on the left, we have this so-called smart probe by Pipelife. And this is a battery-fed pressure sensor, so that we also can measure the pressure within the DMAs. And we are installing about 500 of the pressure sensors and 400 of the flow meters, so about 900 to 1,000 sensors in total. And this picture shows our surface area. We have more or less, and that is what you can see by the bigger white lines, more or less 21 independent areas provided with several pumping stations, and each area has its own hydraulic model. And this is what we are going to cut up into 100 DMAs, as you can see by the bluish areas. And then we go to the data foundation. And I think then I'm going to hand over the presentation to my colleague, Ludo Beumer, who is the IT project lead in the program.
Well, thank you very much, Wouter. I'm Ludo. I'm started in the 1st of January in 24. So when Wouter was running the asset infrastructure, we also needed a data platform, and that was the time I stepped in to this program. And I will guide you to the topics involved for the data platform and the data science part. Well, one of the important decisions made in the project is where we're going to host a data solution. Within Brabant Water, we are used to work with Microsoft, and we also had a strong opinion to go to a cloud solution. And Xylem Vue and Idrika have also a lot of experience in this solution. So we did make the choice together to go for this type of hosting. And for us, it was important that it was located also within the Netherlands. So within Middenmeer, we have a data center for Microsoft, and we did choose for zone redundancy. That means that at the Middenmeer, we have 2 physical buildings with the solution. So if one thing happens to the other one take over. If needed in the future, we also can go for geo redundancy in another country. The hosting solution is managed by Idrika and Xylem Vue, but it's within the Brabant Water network. And we also do have the access. So we always have access to the solution provided by Xylem Vue, which was also very important because our important data is in there. Besides the Azure hosting, we also needed a good platform to facilitate all the integrations. And we decided to use the Azure integration platform as a one-stop shop for all API users. We use this for the project, but this also is the future standard for Brabant Water. So this integration layer was new, but also the old integration layers we have, they will be out of order in a couple of years. So this was the right moment to bring this innovative platform and use the integration part. It handles secure access, so authentication and authorization. It handles the request and response. We also can make transformations in the data. Also from performance part, we can do throttling, we can do rate limiting, caching, and monitoring logging. And we also launch within Brabant Water our API portal so that all the API users can access the APIs, can see the specifications, and we did this running the project. Well, what do we integrate via that integration layer from the Azure integration cloud? We have our ERP system where a lot of information is stored. For example, our digital water meters. So our asset information from SAP is transferred through the Azure integration layer towards the Xylem Vue platform. You also did see the family picture where Wouter referred to. So our GIS, our pipes, our network, that information is provided via the GIS integration. So the pipes, the valves, but also connection points, they are integrated. And if there are any if there are any changes in the GIS, the information will be updated in Xylem Vue through the integration. Then we also have a lot of production plans, 29, and production plans provide very valuable information like the flow and the pressure from the water that is produced. That information is running through the SCADA system and delivered to PyOsisoft, and PyOsisoft exposes the data to the Azure integration platform, and we will bring it to the Xylem Vue platform. Well, with all that water meters in our network, we also want to invoice those water meters and the consumption, and that's the reason we also have a integration with our customer system, Mecoms. So we use the meter readings also to automatically invoice our customers. Furthermore, we also decided to not integrate with other vendor platforms for sensors or water meters. So we did have some pilots in the past, but we are going to replace them by modern technology. So we did make the decision not to put any effort in integrating a system that will be removed in the near future. One of the takeaways and the advice it would give, well, don't integrate everything. So make wise decisions. Parts that don't change often. For example, we don't create new production plans every week. Yeah, make a wise decision what to integrate and what not. Dynamic data, of course, but not all the static asset data needs to be integrated, for my opinion. We also have sensors in the field. They are from our supplier Crest. They are pressure and flow sensors. And we have water meters from Sagemcom and Kansloop. All those vendors, they deliver the information that we need via the Vodafone platform based on narrowband IoT technology directly to the Xylem Vue platform. For the data loggers, that can be near real time or once every 10 minutes if they are battery powered. For the water meters that we now have in our network, it's once a day, 24 values. But we are also looking to solutions to have that for bigger customers, also near real time, because those customers have a huge impact on the consumption and the water in the network. And also one of the takeaways I can give is, well, don't stick to vendor platforms. If you are able to extract the data without the vendor platform, you also are more flexible and also not tailored to their solution. So you have the data in your own system and you can do anything with it what you like. Well, then I go to the portal and the Xylem Vue platform. When we started, I think it was 4 years ago, the platform was not that well equipped as it is now. So also during the project, a lot of capabilities on the Xylem Vue platform have been added. So also with a big project like this within Brabant Water, also Xylem Vue and Idrica noticed some new features could be very valuable. So they were placed on the roadmap and some of them have already also been delivered while we're running and we're integrating the project. The platform, it's also important to have a safe access. So we decided to create the in-log via single sign-on. So our Brabant Water users don't need to enter their passwords separately. It's well administered, and they can easily actually use it. User management is quite, there's a lot of settings that you can create. So it's also good to determine certain roles and to use to make a mapping between the actually applications, the functions, and the users. On the right part of the screen, you have the overview. This is the portal. And as a functional manager, I'm also able to change this view. So I can add icons, I can change things. So you have the flexibility to arrange it what is best for your users. When developing a project like this, there are three main parts. Well, we have the Xylem Vue product and the modules. So they are developed by Xylem Vue. They have their own roadmap. They have own product owners. So that's a standardized product. On top of that, we have the tailor-made integrations for Brabant Water, and you have the implementation and configuration. So those three parts together, they make the solution. So there's a lot of tailoring in that part as well. So it's also good that you have a environment strategy and testing incorporated in all the right environments. Then I go to some modules. We have the Xylem Vue Smart Water Engine. And one of the heart of the system is the DMD module, Domain Master Data. Well, the name says it. All the data from our network and the assets that are in there, they are well structured and available in the platform, and also integrated where applicable. So that's the static data. And then we have a module called IoT Core. That's where all the dynamic data will be available in the platform. So the water meter readings, also the sensor data, everything that is real time and changed often is in that module covered. To monitor our data loggers in the field and the sensors, there is also the capability device management that you can use, where you can have the overview which devices are installed, when did the latest information was received, and how is it with the battery condition. That kind of information is provided in that module. We have the port, that's the DT builder. That's the capability that the hydraulic modelers from Idrica and our colleagues use to also build the modules for the real-time what its scenarios. Well, now we have the assets. We have the data from the assets, static and dynamic. So then we go to the third level of the pyramid, the data science tooling on top of that. There are some really nice modules within Xylem Vue. One of them is unified network management. This is used by our control room to see pressure drops, changes in the flow, and they can act on leakages in the network based on the dashboards they have been made in the unified network management. So all the data that's in the platform can be visualized, as you see on the top left, in the bottom left. Then the real-time what-if scenarios, that is the actual digital twin. Wouter will give the demo from that part as well. This is where you can run scenarios. So what if we change something in our network, or we stimulate a burst, what will happen with the other part of the network? And I think it's the most valuable part of the platform, so that you can predict what will happen if a certain scenario takes place. Then we have the leak detection module. Within Brabant Water, we have a relatively low amount of non-revenue water, but still this module can be very interesting, because certain areas can have a relatively high amount of water loss. And this module will give insights on DMA level, where we have leakages that we don't know at the moment. Then we have a metadata analytics module that is used for our smart water meters. Perhaps you can imagine if you are installing thousands and thousands digital meters every week, that it's good that you can monitor the rollout, that you can see if they are placed, if they are delivering the data. This module gives that insights, and it also gives the insights of the consumption in a certain area for our customers. And in the future, we will use this information also for advices to our customers about water reduction and give better insight in their usage. But this is for the near future. And then we also have the operational intelligence parts that are dashboarding that's been arranged, where we can see the overall performance of the platform and the network, and can also bring additional validations to it. And this is how we came from the data, the hosting, the integrations, and the modules of the platform